Waves. Let's do some revision on waves. We have two types, transverse and longitudinal. So, transverse waves have wave displacement that is perpendicular to the direction of wave propagation. And examples of transverse waves can include light, radio, water, and seismic waves. And for longitudinal waves, it considers particles of matter. So let's consider sound waves and how they travel through air as an example. Sound waves travel in a series of compressions and rarefactions, and at points of compression, the molecules of the medium are packed tightly together, resulting in a pressure increase. But at points of rarefaction, the molecules are further apart, resulting in a pressure decrease. And the direction of wave propagation, as shown in the following diagram for a longitudinal wave, is backwards and forwards, and the direction of wave displacement is exactly the same. So to properly define this, for a longitudinal wave, you would say that the direction of wave displacement is parallel to the direction of wave propagation. And examples of longitudinal waves include sound and P waves. Moving on, we now need to consider some key definitions of the wave. So let's start off with the wavelength. The wavelength is defined as the distance measured in the direction of wave propagation between two successive points that are characterized by the same phase oscillation. So if we look at the following diagram on the left hand side, we see that from peak to peak, obviously those 2 points are of the same phase, and the distance between that is defined as the wavelength as shown by the following purple line. Now to define frequency, imagine that you have a dotted red line going down, and that measures the amount of oscillations passing that given point every second. That is defined as our frequency. And the amplitude of a wave is defined as the maximum extent of an oscillation or vibration measured from the position of equilibrium, with the position or the point of equilibrium being the horizontal black line going along the x-axis. And the period of a wave is defined as the duration of one complete wave cycle, as shown by the following blue dotted lines. Moving on, we now need to consider polarization. Well, what is polarization? Polarization is the process of restricting electromagnetic vibrations, especially light, to one direction. The device that allows for this process to occur is known as a polarizer. So if we take a look at the following diagram, diagram number 1 on the right hand side, initially we have unpolarized light with its electric fields vibrating in many different planes, and this unpolarized light propagates towards the Polaroid filter, and as it reaches the filter, the electric field that is parallel to the transmission axis of the filter is then transmitted through, and in this way unpolarized light becomes polarized. Now let's consider having two Polaroid filters. So the same idea applies again. Unpolarized light propagates towards the Polaroid filter. The electric field parallel to the transmission axis is transmitted. All other orientations of electric fields are absorbed by the filter, and as you rotate the second filter, the amount of light passing through decreases, and this is due to the vertical component of the second filter's transmission axis decreasing. So when the two filters are at 45 degrees to each other, the intensity of light will be a half. And when those two filters are perpendicular to one another, the intensity of light will be 0. Moving on, we now need to consider the applications of polarization. So imagine we have sunlight as our source of light. So sunlight is unpolarized, and unpolarized light is directed towards a reflective surface, which in this case is glass. And glass basically causes light to become partially polarized, and this is due to the process of polarization, which is defined by the plane of the reflective surface. So the plane of glass is vertical, and therefore only vertical light is reflected into the stickman's eyes. However, this can cause a problem because this light is entering into our eyes. This causes glare. To remove glare, what we need to do is construct Polaroid glasses with filters that are of basically a different orientation to that of the light that is entering into our eyes. And in this way, light can be completely, or glare can be completely removed, and therefore would allow you to see more clearly. Thank you all for watching. I hope this video has made sense and cleared any questions anyone's had regarding polarization and key definitions on the wave, as well as the types of wave. Please like, subscribe and share. It would be much appreciated. Thank you all for watching, and goodbye.